Okay, so picture that one chair in your bedroom. Yeah, you know the exact one I'm talking about. It's covered in those clothes that are, well, neither clean enough to put away, but not really dirty enough to actually wash yet. I was looking into this whole laundry dilemma recently, and it turns out we might literally be entering a world where the chore of doing laundry just doesn't exist anymore. Welcome to this explainer. Let's discover the science of self-cleaning fabrics together. But to really get why this is such a game changer, we have to start with this absolutely staggering number: 13,000 liters. That is the amount of water an average household uses every single year just doing laundry. Our traditional washing machines are creating this massive environmental problem, draining freshwater resources and polluting our waterways. But thankfully, material science has an answer.
Okay, let's dive right into this. Here is the roadmap for today. We're going to look at the end of laundry, nature's super repellent secret, sun-powered stain eaters, how we make smart clothes a reality, and finally, the environmental trade-offs.
All right, starting off with part one, the end of laundry and the massive cost of clean clothes.
So, beyond that huge water footprint we just mentioned, traditional laundry is eating up nearly 9% of total household electricity. 9%! And you know what the ultimate irony is here? It's actually terrible for your wardrobe. Between the high heat, the harsh chemicals, the intense friction, we are literally destroying our favorite clothes piece by piece just trying to keep them clean.
Moving right along to part two, nature's super repellent secret and the physics of the shield.
To fix this whole mechanical nightmare of washing machines, scientists actually looked to biology to see how nature flawlessly repels water. And they found something called the lotus effect. If you've ever seen a lotus leaf right after a rainstorm, you know the water just beads up and rolls right off, taking all the dirt with it. Now, we used to just assume the leaf must be perfectly smoothly like glass to do this. But remarkably, it's the exact opposite. It actually stays clean precisely because it's incredibly rough on a microscopic level. It's covered in these tiny little bumps called papilla, which are then coated in nanoscopic wax crystals. So, to bring this natural phenomenon to our clothing, engineers look at two very different physical states. First, we have the Wenzel state. This is where water fully penetrates the microscopic crevices of a fabric. And this completely ruins it, because the high adhesion basically pins the water and the stains directly into the material. But then we have the magic, the Cassie-Baxter state. Think of it like a microscopic bed of nails. The water droplet rests only on the very peaks of those tiny bumps, and trapped right underneath it is this little cushion of air. The adhesion is so incredibly low that water just simply rolls right off, grabbing dust and dirt as it escapes. All right. Part 3, sun-powered stain eaters, or the chemistry of the sword.
Now, what's really interesting here is that a physical shield, like the lotus effect, is great, but oils and sweat can actually breach it. We need an active chemical mechanism, a sword, to complement our shield. Enter the photocatalytic cycle. By embedding semiconducting metal oxides, like titanium dioxide, into the fabric, our clothes basically become active chemical factories. Here's how the whole shebang works. Step 1. The titanium dioxide absorbs ultraviolet light. Step 2. This solar energy excites the electrons, causing them to jump and leave behind positively charged holes. Step 3. These charge carriers react with the ambient moisture and oxygen in the air to create reactive oxygen species, or ROS. These ROS are literally like microscopic Pac-Man. And finally, step 4. They aggressively eat up organic stains. We're talking coffee, wine, sweat, and they completely destroy bacterial cell walls, breaking them all down into harmless carbon dioxide and water. I mean, just pause for a second to appreciate the sheer speed and efficiency of this. Titanium dioxide coatings can degrade up to 95% of organic stains within just 20 minutes of sunlight exposure. Seriously, you spill red wine on your shirt, you step out into the sun, and your shirt literally eats the stain and turns it into an inert gas. It sounds completely like science fiction, but no, it's pure applied chemistry. Which brings us to part 4, making smart clothes reality, from the lab to your closet. And this brilliantly illustrates how we're actually transitioning this tech into the real world. There's a wild, diverse range of commercial implementations already out there. You've got Scheller Nanosphere, which embeds silicon nanoparticles to mimic the lotus leaf directly for outdoor performance apparel. Then you have this highly futuristic tech like Fabrican, which is a literal spray-on liquid polymer suspension that instantly forms a seamless garment right on your body. No way, right? Or alternatively, manufacturers are using fused filament fabrication to essentially 3D print fabrics. By just tweaking the printer settings, they can build that microscopic roughness right into the physical weave structure itself, totally bypassing topical chemicals. But of course, you can't just spray on some magical dust and hope it survives the washing machine.
To survive our daily wear and tear, scientists have to use advanced anchoring techniques. They're utilizing really intense processes like radiation-induced covalent grafting to permanently lock these nanoparticles directly into the cotton fibers so they simply won't wash out. And importantly, the industry is also shifting aggressively to fluorine-free, eco-friendly formulations just to ensure that the chemistry keeping your clothes clean isn't simultaneously toxifying the environment.
And that leads us perfectly into part 5, the environmental trade-offs, balancing the scales.
So the crucial point is stepping back and looking at the macro impact. The math here is just incredible. If we skip just one single wash a week per household, thanks to self-cleaning clothes, we reduce our water consumption from 13,000 liters down to 11,300 liters. That saves 1,700 liters of pure water per household every single year. Plus, by minimizing that brutal washing and drying cycle, we extend the physical lifespan of our garments by up to 50%. We literally stop throwing away fast fashion simply because it wore out in the tumble dryer.
However, we do have to be honest and weigh the other side of the scale. What are the actual ecotoxicological risks here? Well, if these functional nanoparticles peel off during a rare wash, they can leach into municipal wastewater. Loose silver nanoparticles, for instance, possess really strong non-selective antimicrobial properties that can actually destroy the beneficial microflora in our soil and in wastewater treatment plants. Plus, there's an ongoing question of dermal safety, like can these active particles cross our skin barrier? So strict regulatory compliance and permanent chemical anchoring are absolutely vital to prevent pollution and protect our health.
Which leaves us with this final, truly provocative thought. The science to practically end laundry, it's already here. The environmental savings in water, electricity, and textile waste are undeniable. But are you ready to trust active nanobots and complex chemical coatings sitting directly against your skin to help save the planet? It's a fascinating trade-off, and one that might just completely revolutionize what we choose to wear tomorrow. Thanks so much for joining me on this explainer. Keep asking great questions, and I'll catch you next time.